Today we're going to learn a new phrase in mathematics that you're going to hear quite a bit over the next little bit. That new phrase is called rationalizing the denominator. You already know what a denominator is. That's the bottom of a fraction. The word rational comes from your number systems. We have rational numbers and we have irrational numbers. So this word rationalizing the denominator says we want our denominator to be a rational number. So for example, you are no longer going to be allowed to have square roots on the bottom of fractions. You are going to have them equal to a rational number on the bottom of the fraction. Well, how do we do this? It gets back to an idea you already know. If you were adding fractions, you need a common denominator. If that common denominator was 20 and you had 3/5, does it make sense that you would multiply the bottom by 4? But if you multiplied the bottom by 4, you also have to multiply the top by 4, because what are you doing when you multiply by that 4 over 4? You're multiplying by 1. And last time I checked, when you multiply by 1, you don't change what it's equal to, right? You don't get a new number. 7 times 1. Oh, I'm still at 7, right? 7 times 2 over 2. Oh, now I'm at 14 divided by 2. Still 7. Right? When we multiply by that 4 over 4, we don't change the value of what we have. We just change. Mr. Vermat is trying to call me. He's got to know that I teach. We don't change the value, we just change what it looks like. This is going to be the idea of rationalizing the denominator. We're not changing the value of our answer. We're changing what it looks like so that we have a rational number on the bottom. So if you had 1 over root 2, if you multiplied by root 2 over 2, this I was going to do purple, but that looks black. That in the black box there is equal to 1. So if I multiply by 1, I don't change what my answer is equal to. I just change how it looks. And when I multiply a root 2 times a root 2, I get root 4, which is 2, and now my denominator is a rational number, and I have rationalized the denominator. So, we're going to find out in grade 11 math. A fraction is never simplified if you have a square root on the bottom. So if you would have left your answer as 1 over root 2, I'd have to take off a half a mark for not being simplified. Okay? This is the rationalization of it. Historically, the reason for this was before calculators, and I'm just going to randomly put stuff out there. If you wanted to get this and do a method for doing this to 5 decimal places, it might take you 6 hours of work. If you wanted to do this without a calculator and get 5 decimal places, it might only take you 45 minutes without a calculator. So 45 minutes is a lot less mental math and work compared to 6 hours. Without a calculator, in the green box, this is very hard. Without a calculator, the final answer is just hard. Part of the problem right now is we have calculators. Would you ever be asked to do either of those without a calculator? No. To get a decimal place to 5 decimal places? No. So the idea of simplifying is sort of historic, that goes way back to before calculators, and how much easier this was to calculate than that. But there's some nice mathematics that happens as a result when we rationalize that comes up later, so this process is still very important. So we call this the simplified form, and this is rationalizing the denominator. And we're going to get 2 different situations. Situation number 1, we just have a square root on the bottom, like 5 over 2 square root of 3. I've have a square root on the bottom. I might even have extra numbers, like I have the extra 2. What gets rid of the square root of 3? Is the square root of 3. So I would multiply the top and bottom by the square root that would get rid of the square root. Because what would I get? If I really took my time here, I would get 5 root 3 on the top and over 2 times root 9 on the bottom. Because root 3 times root 3 is root 9. However, most of you will skip this step and say, I know that root 3 times root 3 is going to be 3. 3 times 2 is 6. This will be one kind of rationalization that we'll have to do. The more difficult rationalization that we'll have to do, the second kind, is when you have 2 square roots or 2 things on the bottom, a binomial on the bottom. It doesn't have to have 2 square roots, 1 square root and a number. And there's something we've done in yesterday's lesson that is the hint for getting rid of both of those square roots. Can you see in the last 2 examples something that we've done that would get rid of both of those square roots? Difference of squares. Because if we do the difference of squares, so in the second one, if you see the difference of squares, what's nice about the difference of squares is that this will be root 2 squared minus root 3 squared. And on the top, you'd have to distribute, so you'd have 5 root 2 plus 5 root 3. And the nice thing, my top, there's nothing I can do on my top because those are not like terms. But root 2 squared will just be 2. Minus root 3 squared will just be 3. And you'll get 5 root 2 plus 5 root 3 all over negative 1. And now my denominator is a rational number again. So you're going to have 2 different types of these questions. One type where it's just a regular square root, just a monomial. Second type where it's a binomial. And actually the second type, seeing the difference of squares and understanding that, super important in calculus as well. Comes up quite a bit in calculus. So let's go to example 3. We just have type 1 here. I have a square root on the bottom. So I'm going to rewrite, set it to rewrite. I'm going to rewrite my question, 5 root 7 plus 3 over root 7. And then I need to multiply by 1. And the one that I need to multiply by, I have to get rid of the square root on the bottom. What could you possibly multiply the square root of 7 by to get rid of the square root? Square root of 7. So we multiply top and bottom by square root of 7. We have to imagine this top is all together. It's in brackets. So when we multiply by that new root 7, it's going to distribute. What does that give me as a result? Well, this root 7, when it distributes to the first one, okay? Can you do it in your head and get the final answer? Are you fine if I just write 35? Okay, because the root 7 times root 7 will just be 7. And then I still have to multiply by 5. That's 35. The root 7 times the 3, well, that's just 3 root 7. All over root 7 times root 7 is 7. We are getting into a lot of details in math now. Some of you are going to be tempted to simplify it because you see the 35 and the 7. In mathematics, we can simplify fractions if we're multiplying on the top and there's a factor that's identical. Right now, we're adding on the top. It's like an order of operations that there's brackets there, even though brackets don't have to be written. So if you're adding on the top, unless there's an identical factor that's adding on the bottom, we cannot simplify this at all. You can only simplify if you're multiplying on the top. And so this is simplified. And I think this is kind of funny because up till now, the English language, if you see the word simplify, you would expect your answer to look more simple than it did before. Does the answer look any less complicated than our beginning? I don't know. They both look kind of complicated looking. There's our final answer. 35 plus 3 root 7 all over in B. Wow, that's yellow. In B, I am going to rewrite it 6 root 2 minus 4 root 3 all over the square root of 18. And we're asked to simplify. I'm going to ask you a misleading question. That doesn't sound very nice of me. I'm going to ask you a misleading question. What could you multiply by to get rid of the square root of 18? You want to say the square root of 18. Does that not make sense? That to get rid of the square root of 18, you should multiply by the square root of 18. That is correct, but if we do that, I'm going to tell you it's not wrong, but our life will get more difficult. I'll do it in the end, but I won't do the more difficult way first. If we can, you see something?
I was just saying, could you do the square root of 2?
You could do the square root of 2, because that'll make something easier. But the reason you can do the square root of 2 is if we simplify the bottom first. Right? The question said simplify. You see that this is a mixed radical. It's not a mixed radical. It's not in lowest terms. 18 is 9 times 2. You don't really have to know your times table like this, because you have to see numbers and right away go, hey, that's 9 times 2. I can rewrite this square root of 9 times square root of 2. It'll be 3 root 2. Which is why what Stone mentioned works out so nicely. Now what's the square root I have to get rid of? I have to get rid of the square root of 2, which is smaller than the square root of 18. So if I multiply the bottom by the square root of 2 and the top by the square root of 2, again here at the top, I have to imagine there's imaginary brackets there that are invisible. That square root of 2 is going to have to get distributed. It's going to give me 6 root 2 times root 2 will be 12. Because the root 2 times root 2 will be 2. And then 2 times 6 will be 12. Minus root 3 times root 2 will be root 6, so that doesn't simplify. I get minus 4 root 6. And on the bottom, the root 2 times root 2 is 2. Still times by the 3 is 6. And we're not done yet.
$30.
Okay. I'm going to finish this question, and then so, from here, there are 2 terms on the top, 1 term on the bottom. Do you see that they all have something in common? There's something that divides all of them. You can divide them all by 2. The fact that you can divide them all by 2 means that we can, and I'm going to write this here, divide that one by 2, divide this one by 2, divide this one by 2. Mathematically, that's allowed. The reason it's allowed in the step that I didn't show, if you want to show this, we could say I can factor out a 2 out of the top. is 6 minus 2 root 6. And because I technically changed this to a multiplication, that allows me to simplify 2 over 6 is 1 over 3. And lets me change this to a 1 and this to a 3. However, sometimes writing that extra step out confuses you more than it's necessary. So mathematically, if you have a fraction with more than one thing adding or subtracting on the top, the only way you can simplify something is if you find something that divides all 3 of them, or if there's more, all 4 of them. Is there something that divides all of these? Yes, everything can be divided by 2. So we imagine you could factor out a 2 at the top, factor out a 2 on the bottom, and cancel them out. And because when you factor, you change to multiplication, simplification is allowed. So that's part of the details that are happening in the background. We're going to start to notice, and I noticed it on your quiz. I started marking your quiz. I was going to finish it this morning, but I left it at home. But I noticed on the first page of the quiz that we're making a lot of mistakes because we're missing a few details. And we've got to get really good at those details to make less mistakes. Okay, so questions for practice, and you can work on them right now. 6, 9, 13, I, and 14.